adding and subtracting real numbers is where we condense what would have been more like 3 weeks or 4 weeks in 7th grade, and we combine it into one lesson. And that's because you've already learned this. It's just a review. So you're not going to see a lot of new stuff in this lesson. The learning target, what it is we're trying to accomplish, is that you can find sums and differences of real numbers. And remember, by real numbers, it's going to be pretty much all the numbers that you can think of. Absolute value is a concept that is really much easier than what you would think it would be. It's one of those words that sounds scary, but it's not at all. It is the distance away from zero. And it's these bars outside the numbers. When I ask you about absolute value, you can definitely tell me about it, but it's often these bars that you forget about. So those bars, what they mean is take the absolute value of -3. How far away is -3 from 0? Well, you can see on this graphic it's 1, 2, 3 units from 0. Therefore, the absolute value of 3 is 3. Now, if we take a positive number, the absolute value of 4, it is 1, 2, 3, 4 places from 0 on the number line. So the absolute value of 4 is 4. Now, to just simplify this, you drop the sign. The absolute value is the number without a sign. For adding real numbers, you have to think about having same signs or different signs. So you look over here on the same signs. If you'll remember, when you have the same signs, a positive plus a positive, a negative and a negative, you find the sum of the absolute values. So 3 and 4 is 7. I add their absolute values and I keep the signs. Since these were positives, I get a positive. You may remember where we had counters and we cancel out 0 pairs and stuff. That's going to come in different signs. But we're past that. We're not having to use some sort of representation for it. You can do this in your head. This is just recap. Or if you have like -3 plus -4, they have the same signs. So I take the sum of the numbers. 3 plus 4 is 7. And what should be there, let's add it. Go back there. That should be a negative sign right there. Glad I caught that. Okay, so now for different signs, you take the difference of the numbers and you subtract their absolute values. So -3 plus +4 would be 1. That's because the difference between 3 and 4 is 1, and you conduct a sign OR, meaning which one is bigger. Do I have more positives or do I have more negatives? I have more positives, therefore it is +1. Think about it in terms of money. You owe your mom $3, -3, and then you somehow acquire $4. You know, I don't know, put your clothes away or something, and somebody gave you $4 for it. So you have to use 3 of those dollars to pay back your mom to make a 0 balance with your mom, and then you have $1 left over. Now, a flip side of this, if I had a +3 and a -4, the difference is still 1, but I have more negatives, therefore it is -1. The existence of additive inverses is a property, and what it says is that for every number A, meaning like A, not like it's like a variable, whatever number that could be. For any number, there exists the negative form of that number, -a, so that the number and its negative is equal, the same thing as its negative plus its positive, and that's going to equal 0. So put some numbers with this. 6 plus -6, of course, is the same thing as -6 plus 6. So what that's telling you is the order doesn't matter, and it's 0. This is also known as a number's opposite. So the inverse property of addition, what that says is the sum of a number and its additive inverse or opposite is 0. You'll hear subtracting integers explained a lot of times that you add the inverse, and you'll see that in the next slide. So A plus -a is 0. 6 plus -6 is 0. Very similar to what you just saw. So for subtracting real numbers, this is where you're adding its opposite, and this is where you have the keep, change, change, and we can sing keep, change, change. If you were a friend of mine last year and you got to hear that from me, or maybe Miss Pace or Miss Jones, or who is Miss Carnes, whoever else, they might have taught that to you as well. But we'll have a good singing, good time with this, and we'll dance around with it. So the keep, change, change, what that says is you keep the first number, and I've brought this in black here. So -8, I'm going to keep that number, so you can see that it stayed -8. Change is you change subtraction to addition. That subtraction sign changes to addition. And you change the second number to its opposite. I have that in blue there. Negative 13 is changed to positive 13. So negative 8 minus negative 13 sounds kind of crazy and hard on your head, but really what it means is negative 8 plus 13. And then I think about my adding rule. Since it's an adding problem now, negative 8 and positive 13 are different signs, so I take the difference of those numbers. The difference is 5. I have more positives, so my answer is positive 5. This is a graphic organizer that I want you to go ahead and put on a separate sheet of notebook paper. So go ahead and get that out. Don't put this in your notes. Put it on a separate sheet of paper. This is going to be one that you're going to hang on to. If you happen to have cardstock or construction paper or, colored paper or something, get your highlighters out, get your colors out, make this real pretty because this is something you're going to refer back to. Go ahead and get this formatted out. We're not going to fill it in right now in the lecture video. That's going to be something we're going to do tomorrow in class. On the back side of that paper, I want you to write out your decimal rules. I'm not reteaching these to you in a video because you have been adding, subtracting, multiplying, and dividing fractions and decimals for a few years now. You should be pretty good at this. For you being in Algebra 1 as an 8th grader, you should have this mastered. We're just going to use this to organize our rules tomorrow in class. So you don't have to fill it in. Just get it formatted, get that copied down, and you can do this on the back side of your fraction rules. Let's put these rules of adding and subtracting real numbers into practice. Let's start over here with negative 9 plus negative 3. They have the same sign, so I'm going to do the sum of their absolute values. 9 and 3 give me 12, and they're both negatives, so it's going to stay negatives. If you'll think of negatives in terms of money and debt and actual money that you have, it makes sense. If I owe my mom $9 and I owe my dad $3, that means I'm in debt altogether $12. Nothing is going to cancel out there. Let's look at practice B. 7 over 9 minus negative 5 over 12. I suggest you deal with the negatives first. Subtracting, the rule is to keep the first number, change. We are adding the opposite. So subtraction changes to addition, and negative 5 over 12 changes to its opposite, positive 5 over 12. Now it's not quite as scary, positive and a positive. With fractions, you have to get the common denominator, which would be, 36 is what it would be. So this is going to be something over 36 plus something over 36. To go from 9 to 36, I multiply by 4. 7 times 4 is 28. To go from 12 to 36, I multiply times 3. 5 times 3 is 15. Now I'm going to add my numerators. 28 plus 15 would be 43 over 36. I have an improper fraction. I'm going to change it into the mixed number. 36 goes into 43 one time with, 7 left over. So it is 1 and 7 over 36. I'm going to come down here to practice C. I have 4 different numbers that are going to be subtracted. I'm going to go ahead and if I do keep, change, it's going to be keep, change, keep, change, change. I have all these negatives and I have this positive. What I'm going to suggest is using the commutative property in our benefit. I'm going to combine my negatives and then I'm going to add that to 1. Because when I'm adding negatives, they all have the same sign, which means I'm going to find the sum. I need a common denominator, which is going to be, not 8, but 12. So I'm going to keep that 1 plus something over 12 plus something over 12 plus something over 12. 1 over 2 becomes 6 over 12. 1/3 becomes 4 over 12. 1/4 becomes 3 over 12. So I'm going to skip the 1 now and go to these 3. So commutative property says I change the order. I'm going to add those first. And since they all have the same sign, I'm finding the sum of all those. 6 plus 4 is 10. 10 plus 3 is 13. So I'm going to have negative 13 over 12. So I have the whole number 1 plus negative 13 over 12. Think of 1 as 12 over 12. Go ahead and give it a common denominator. So I'm going to add their numerators. 12 plus negative 13 is negative 1. Therefore, my answer is negative 1 over 12.